Welcome all to Basic Maths Class 7. So in the previous class we discussed how to differentiate an algebraic functions. Now here we'll discuss about differentiation of trigonometric functions. So in differentiation of trigonometric functions like sine theta, cos theta, tan theta, etc., you have to directly remember the differentiation of all these functions. Like differentiation of sine x is nothing but cos x dx. Differentiation of cos x is minus sin x dx. Differentiation of tan x is sec square x dx. Differentiation of cosec x is minus cosec x cot x dx, and differentiation of sec x is sec x tan x dx, and differentiation of cot x is minus cosec square x dx. So you need to remember all these differentiation of trigonometric functions, and in your 12th class mathematics you learn how the differentiation of sin x is cos x and cos x is minus sin x, etc. For physics we now need to know the derivation for that, but you should remember that the result. Now over here this differentiation also we are finding out by using the same way. When there is a change in value of x, what happened to the value of change in y, and we are finding out the value of dy, and the direct result we are written over here. So anyway, if you'd like to come to know that like why differentiation of sin x is cos x dx, something like that, so I'll try to explain it, but it's not necessary that you'll exactly get the complete meaning of what I'm trying to explain. That you learn in your 12th class mathematics. So let's say anyway I'll try to explain it. If y is equal to sin x, now we know that when the value of x becomes x plus dx, so we can write sin x becomes sin of x plus dx, then the value of y becomes y plus dy, and our aim is to find out the value of dy or dy by dx. So instead of y we can write it is nothing but sin x plus dy is equal to, this is basically in the form of sine of a plus b. So we required some trigonometric relation for it. Some students might be knowing it. Sine of a plus b, if you don't know, there is no problem, you learn in 12th class. Sine of a plus b is nothing but sine a cos b plus cos a sine b. By using that we can expand this. Sine of x plus dx can be written as nothing but sin x into cos dx plus cos x into sin dx. Now we can write this sin x plus dy is equal to, over here I'm just writing the sin x as it is, cos dx. Already we discussed that this dx is a very small value, like you can say that it is like 0.000001, or as the value of dx tends to 0, the value of cos dx, like cos 0, will be equal to 1. So this cos dx can be written as nothing but 1 plus cos x into sin dx. For small values of theta, like again we are taking as this dx is a very small value, for small values of theta, sin theta can be written as theta or it can be written as tan theta. I'll explain it separately. Now the sin dx can be written as nothing but dx, because dx is a very small value. So we can cancel the sin x and sin x, so the value of dy will be equal to nothing but cos x dx. That's why we are writing differentiation of sin x is nothing but cos x dx. Or if you'd like to find out the value of dy by dx, we can write this is equal to nothing but cos x. So like that, derivation is there for each and every trigonometric functions, but now you just remember the equations. Now I'll explain in between the derivation we discussed that for small values of theta, sin theta can be written as nothing but theta or tan theta. We'll discuss why it is like that. So we know that we are writing all these trigonometric equations like sin theta, cos theta, tan theta, etc. for a right angle triangle. So assume that for a right angle triangle with side x, y and hypotenuse, take it as z, and let's say this angle is equal to theta. So we know the equation for sin theta, which is opposite side y divided by hypotenuse z, and the value of cos theta, we know that it is adjacent side x divided by hypotenuse z, and the value of tan theta, which we can take it as opposite side y divided by adjacent side x. Now we are considering a situation. Along with that, just remember what do you mean by theta also. What is the definition of theta or angle? So the definition for angle is nothing but angle theta is equal to length of arc divided by radius. Now we'll discuss what do you mean by length of arc divided by radius. If you are just considering a circular path or circular arc, and let's say this arc making an angle theta with respect to its center. So this is representing nothing but its radius, and this we can take it as length of this arc, let's say L. So the definition of theta is length of this arc L divided by r will give the value of theta. So just remember what do you mean by sin theta, cos theta, tan theta and theta, and you know that reciprocal of sin theta is known as cosec theta, reciprocal of cos theta is sec theta, and reciprocal of tan theta is nothing but cot theta, and along with that you just remember that sin theta by cos theta is tan theta. Now we are just considering a situation for a very small values of theta. So for a very small values of theta, I can draw this triangle something like this. Assume that for a very small values of theta like 0.00001, something like that. So I'll try to draw it something like this. So over here you can observe that this angle theta is very, very small. Okay. Now even for a differentiation, we are not considering even this much higher values of theta. It will be much less than that. So in such a situation, we can say that this adjacent side x and the hypotenuse z will be almost same, and this we can take it as nothing but y. Now if I am writing the equation for this theta, so I can write the value of sin theta will be equal to opposite side, which is y divided by z, and the value of tan theta can be written as nothing but y divided by x. And if I'm just considering it is like a arc and radius, so we can write this theta is going to be length of arc, we can take it as y, and radius we can take it as something but x, z. Over here for small values of theta, the value of z is going to be equal to nothing but x. So we can say that the value of sin theta, which can be taken as y by z, tan theta can be written as y by z, and the value of theta also can be written as y by z. That means for small values of theta, the value of sin theta is going to be equal to tan theta, that will be equal to nothing but theta. So that's why we are taking this assumptions. And same as like that, if we are writing the equation for cos theta, so for small values of theta, from this triangle cos theta will be equal to adjacent side x divided by z, and you know that this x is approximately equal to z, so the value of cos theta will be tends to 1. That's why on that derivation we took it as for small values of theta, cos theta is 1 and sin theta is equal to tan theta is equal to theta. So in physics, in many questions we'll use this concept, so just remember these things.